Okay. So write a possible equation for the graph below. So what is that going to look like? Go ahead. We'll talk about it in just a second. Ready? So what, Ellen? There's 2 bounces and 1 cross. So you're gonna pick like a number that's over here. So like 5. Okay. So we're gonna say x plus 5, and what's the exponent that we're gonna use? 2. Okay. And then you're gonna pick another point over here, which is 3. So we got x plus 3. And then we've got the next one. So what is that gonna be? 2. Okay. And what exponent? Okay. So everybody see where the bounces are even and the crosses are odd. Okay. So you could have written something else. If you wanted to change the numbers, that's fine, as long as those exponents were the same, right? Now you're going to title this one Sketching Graphs. Sketching Graphs. Sketching Graphs. Find some x-intercepts really quick. So we're going to write a possible equation for the graph below. So we've got zeros at -a, -b, and c, right? Okay, so when we write the equation, what do? Switch the sign, and then whatever the exponent is based on the shape of the graph. So is this a cross or a bounce? Okay, and so that's going to be an exponent of 2. Right here, we've got a cross. So again, we're going to switch the sign. And then my exponent is going to be 1 because it's going to be a cross. Right here, we're going to have x minus c. Somebody needs to change anything. And the exponent is going to be 2. Nope. Okay. Okay, if you have a 4th degree polynomial with only 3 unique factors, what must be true?
One must have a degree.
Okay, one must have a degree of 2. Okay. Okay, or a multiplicity of 2, right? I would like, you don't have to write the entire thing, but you can shorthand, just write the first sentence, and then maybe one must have a degree of 2. If you changed which of your factors had a multiplicity of 2, how would the end behavior of your graph change? If you change the multiplicity of one of your factors of 2, how would your end behavior of your graph change? It's not necessarily an even graph, but what if, like, for instance, if I did this versus this. Oh, nope. It doesn't really change much, right? But what about if I had something like this? If I did, if I had an even degree polynomial, it would maybe look like that. Or I could change my behavior some way, right? Like, it just kind of would depend. So it would change direction of in behavior. Okay, so it could impact it. It could keep it the same. Okay, it just kind of depends on what the actual equation is. What is one number you could change in your equation that would result in a graph with a different end behavior? What's our biggest thing?
Negative.
Okay, changing it to negative. So changing one of the x's to negative. And I'll give you a second to write that down. Okay, so we have this expression, and we're given that x minus 4 is a factor. And here are the steps to how to draw and find and determine the end behavior. Okay, so these are the things that we're gonna do. Okay, so on my paper, I would write example 1. I would write this equation out. I would say given x minus 4 is a factor. Diani, go. Okay, so that means that we're gonna have a 0 at 4, right? Now we got to figure out what the other factors are. We got to find the other zeros, right? So what we're gonna do is looking at our equation, okay, what can we take out from each one of these? What can we take out from each one of these? X to the third, right? Okay, so let's go ahead and do that. When we take out an x to the third, we're left with x to the third minus 5x squared minus 8x plus 48. So this x to the third, what is that going to mean? What 0 are we going to have? Okay, maybe I'm asking the wrong question. Looking at x to the third, if we set it equal to 0 and solve, what would we get? 0. We would get 0. But we know that 0 is also going to be a factor or a 0. Okay. Now that we have all of that, what we're going to do is we're going to synthetically divide to help us find the other factors. So we're going to change the sign. We're going to list out the coefficients using the stuff that's inside this parentheses. So 1, -5, -8, and 48. We're going to bring down the first term, multiply, add, multiply, add, multiply, and add. So we're left with an x squared minus 1x minus 12. Okay, I'll give you a second to finish catching up. So now we are going to factor this. Okay, so the way we factor this is we do a times c and b is -1. So what two numbers can I multiply together to get me -12, but add together to get me -1? Multiply to get me -12, add to get me -1. Try again. Y'all are killing me. -4 and 3. Okay, so we can write that out in factored form as x minus 4 and x plus 3. So what are those zeros going to be?
0, 4, and -3.
Okay, so 0, 4, and -3. Okay. Okay, so now that we have that, we're going to write this out in factored form to check the degree. Okay, so watch what I do here, because a lot of people miss this part. We have this x to the third, and we have this x minus 4 and x plus 3. We're missing one of the terms though. Okay. We're missing an x minus 4. That came from this. They told us that information at the beginning. So let me ask you this question. The degree of x equals 4 would be what? 2. Okay, so there's going to be a bounce at 4. There's going to be a wiggle, which we're going to talk about in just a second, on 0. And then there's going to be a cross at -3. What degree polynomial is this guy? Okay, so it's an even degree polynomial. Is it positive or is it negative? Positive. Okay, so we know that the end behavior is going to be facing upwards on both sides. Okay, so now we're going to draw. So at x equals -3, we're crossing. At x equals 0, we're going to have this thing called a wiggle. And then we're going to have a bounce at x equals 4. The reason why we're going to have this thing called a wiggle Okay, the reason why we're gonna have this thing called a wiggle is because it's got an x to the third term. Okay, that's the only one that's a little weird. It's not just a cross. It kind of just like stays on it for a second and then goes back up. Okay, anything to a multiple of 3 that is odd is going to have this happen. So like an x to the 9th, that's what's gonna happen. Okay. Now, what's the end behavior on this? I just said it. They're going up, right? They're both going up. Okay. Take a second, finish writing that. Okay. Are there 3 unique real zeros? Yeah, it touches the x-axis 3 times. That's true. The degree is odd. How do we know?
Because of bounce, so this is 4.
Okay.
Or 6.
Also, both sides are facing one direction. That's how we're going to tell that it's even, right? Yeah. Okay. Because they would be both facing downwards. All right. F of -3. So when x is -3, is y 0? Okay. X minus 5 is a factor. So when x is 5, does it cross the x-axis? Yes. Okay. When f of x is divided by x plus 2, the remainder is 0. No. How do we know? Because x equals -2 doesn't cross the x-axis, right? As x approaches positive infinity, so as we're looking to the right, is y going to -infinity? No. And then is this the equation for this guy? There's a bounce at 2. We're missing that exponent. Fantastic. There is always a question that does like a multi-select, like select all the statements that are true. This is one of those types of questions. All right. So where is the error? We got 3 real zeros. Is that a true statement? Yeah. Okay. As x approaches positive infinity, what's y doing? Goes to positive infinity. So this guy is wrong. Okay. Okay. So if I give you this description, can you draw the graph and write the equation? Take a moment, write this statement down. If we have a 4th degree polynomial and it has x-intercepts at 0, 5, and -2, first thing we're going to do when we graph is go ahead and graph those x-intercepts. The end behavior can be described as when x approaches -infinity, y is approaching -infinity. So that means that it's going to be facing downwards on the left-hand side. And since it's a 4th degree, we know that it's going to both be facing the same direction, right? So we're also going to put this one down. And then now we can just connect it, right? Okay, so we do this. There can be a couple of different answers on this one. You can do it a couple of different ways, as long as your end is facing downwards. Yeah, it does look like a McDonald's symbol. Then when we write out the equation, we're going to say x plus 2 raised to the first power because it's crossing. X plus 0, or we could just put x. We're going to raise that to the second power because it's a bounce. And then we have x minus 5, and that's going to be a cross. So that's going to be to the first power. Okay. So again, there could be multiple answers to this one, but this is just one way to write this. What's the one thing that we forgot to write in this equation?
It has 4 ways.
Because it's got to be facing downwards, right? Okay, here's another one. Okay, so if I'm going to graph this, 7, 5, 6, 7. Okay, so we've got a 3rd degree polynomial. End behavior is as x approaches positive infinity, y is approaching -infinity. So when we graph this, it's going to look like this. Ta-da! Which means that when we write out the equation, we're going to switch the sign. Everything's going to have an exponent of 1, and we're going to have a negative filling out front because it's this way. From a table, I know many a times we struggle from a table. So let me show you a cheat way. So if you look at when y is 0, that's going to be your x-intercepts. So there are your x-intercepts right there. So I'm going to go ahead and graph them. Yeah, they always ask one of the questions in a table format. Okay. Now, they tell us there's negative 720 over at x equals -5. So that means that my graph is going to be facing downwards on the left-hand side. But they don't tell us anything on this right-hand side. Okay. They tell us that we have a cubic polynomial. So that means that it's going to be to the 3rd degree. So when I graph this, we're going to connect the dots. Boom. Okay, first of all, we're going to switch the x values. And we see that it's positive because it's ending upwards, right?